The next method to find out initial basic feasible solution is the lowest cost entry method. I have taken the same questions which we are used to solve using northwest corner method. Before that, the procedure to do lowest cost entry method is choose a cell having the lowest cost in the matrix, allocate there as much as possible, which is the minimum of row total or column total. Okay. So in this cell, find out the lowest cost cell. Lowest cost cell is 1. Here there is 1 in 2 cells. Arbitrarily I am taking the first one. Okay. Then taken the row requirement and column. Row total and column total. Whichever is less, row total. Allocate it here 8 and reduce it to 10. Cancel it and cut off this row. So our reduced matrix have F1, F3, F4. F1, F3, F4, W1, W2, W3. So cost cells are 2, 7, 4, then 5, 4, 7, 1, 6, 2 and demand 7, 9, 10, supply 5, 7, 14. Again look at the lowest cost cell, that is this one. Allocate the minimum of row total or column total. 7 here, cancel, reduce it to 7 and cut off the first column. So reduced table become having only 2 rows column W2 and W3 rows, F1, F3 and F4, 7, 4, 4, 7, 6, 2, 5, 7, 7, 9, 10. Lowest cost cell 2. Allocate 10 or 7, 7. Remaining is 3. Cancel the row. So reduced table become W1, W2, F1, F3. 7, 4, 4, 7. 5, 7, 9, 3. Lowest cost, tying 2 cells. I have taken this for 5, 3. Smallest values 3. Allocate 3 here. Cut off the column. Then last table contain only one column. W1, F1, F3, 2 rows. Costs having 4, 7, 2, 7. These are the supply and demand. Lowest cell this 4. Allocate 7 here. Cross off 2. Only one cell is remaining. 2, 2. Allocate 2 here. Next step is put this allocation in the question. Two, 7, 4, 3, 3, 1, 5, 4, 7, 1, 6, 2, supply 5, 8, 7, 14, demand 7, 9, 18, W1, W2, W3, F1, F2, F3 and F4. Then allocations are in the F2 W3 cell, F2W3 cell, the allocation is 8. Then put all allocation in the question. 2, 3, 7, 7, 7. Number of allocations equal to 1, 2, 3, 4, 5, 6. Which is equal to m plus n minus 1. So total transportation cost two into 7 plus 3 into 4 plus 8 into 1 plus 7 into 4 plus 7 into 1 plus 7 into 2. So total transportation cost become rupees 83. Okay, this is initial basic feasible solution. Since the first condition number of allocation is equal to n plus n minus 1, then the allocation are in the independent positions. Also it satisfies the rim requirement. 2 plus 3 5, 8, 7, 7 plus 7 14. So row requirement satisfied, 7, 9, 18. Column requirement is also satisfied. Okay. Third method is Vogel's approximation method. This is a procedure. Write the difference between smallest and second smallest cost in each row to the right of the corresponding row within the brackets. Similarly, write the difference in each column below the corresponding column. These are called the penalty. Then select the row or column having the largest penalty and allocate the maximum possible amount to the cell with lowest cost in the row or column as the case may be. Then cross off that row or column. In case of tie, select the one having the lowest cost. Select the cell which having the lowest cost. If the penalty is tie, select the cell which having the lowest cost. The third step, for the reduced matrix obtained, again repeat the above two steps and until all the rows and columns totals are exhausted. We can look at the same problem that we were used to solve, and that we were used for solving lowest cost entry method and northwest corner method. This is a question we were used to use in the above two methods. They are having three destination, four origin, supply, demand. First we need to check whether the question is balanced or not. Here the question is balanced. Total supply is equal to total demand. Total supply is equal to total demand. So question is balanced. In the BAM method, the first step is to find out the penalty. We can look at how we are going to find out the penalty. First take the first row. Look at the cost values. Find the lowest cost value 2. Then find the difference between lowest cost to the next higher value. Next higher value is 4. The difference is 4 minus 2 is 2. It should be given in bracket corresponding to the first row. Similarly, second row, the least cost is 1. Next highest value is 3. Difference is again 2. Here the lowest cost is 4. Next highest value is 5. The difference is 1. Here the lowest cost is 1. Next highest value is 2. Difference is 1. This is the row penalty. Similarly, write the column penalties also. In this first column, lowest cost is 1 and next highest value is 2. So the penalty is 1. Here the lowest cost is 3, next highest value is 4. The penalty is 1. Here the lowest cost is 1 and next highest value is 2. The penalty is 1. Then look at these penalties and find out the highest penalty. Here there is a tie, 2, 2. Column penalty, the values are only 1. Row penalty, there is 2. So 2 is the highest value. Here there is a tie in penalty. So first take the first 2 and check the cost values 2, 7, 4. Next, 2 having the cost values 1, 3, 3. Among this value, 1 is the lowest cost. So we need to take this 2 since it having the lowest cost cell and allocate here. Look at the row 8, column 18. So allocate 8 here and cut off that 8 and reduce it to 10 and cut off this row. So our table reduces to 3 rows and 3 columns. F1, F3, F4, W1, W2 and W3. Supply values 5, 7, 14. Then demand values 7, 9, 10. The cost values are 2, 7, 4, 5, 4, 7, 1, 6, 2. Again find out the penalty. Take the first row. The pen had lowest value 2. Next highest is 4. So penalty is 2. Here 1. Here 1. Similarly column penalty 1. 2. Here also 2. Take the highest penalty. There is 3 2's. Take the lowest cost cell. Choose the penalty which having the lowest cost cell. Here it is 2. Here it is 4. Here again it is 2. We can take any 2. I take this one and allocate here 5, 7. So allocation is 5. Cut off it and reduce to 2. And cut off the F and row. So in the next table, the table reduces to F3 and F4, with having only 2 rows, F3 and F4, columns W1, W2 and W3. Cost values 5, 4, 7, 1, 6, 2. And the supply values 7, 14. Demand values 2, 9, 10. Again find the penalties. Here it is 1, here it is 1, here it is 4, here it is 2, here it is 5. Take the highest penalty. Among this value, this one is the highest penalty. In this column, take the lowest cost cell, which is 2. So allocate here 14, 10. Allocate 10 here, reduce it to 4 and cut off W3. The next table having 2 rows and 2 columns. 5, 4, 1, 6. Demand 2, 9. Supply 7, 4. F3 and F4. W1 and W2. Again find out the penalty. The row penalty R1 is 1. Here it is 5. Your column penalty is 4. Here it is 2. Take the highest penalty. This row. Okay, this row having the highest penalty. Among this row, which is the lowest cost cell? This one. Allocate here 4, 2. I am allocate 2 here and reduce it to 2. So this column is reduced. So next table having only 1 column and 2 rows, F3 and F4, W2. Okay. 4, 6. There is no row penalty, column penalty is 2. So lowest cost cell 4. Locate here, demand is 7, 2, here it is 9. Lowest cell 7. Cut off it and reduce 2. So last cell, so allocate 2 here. This is the VAM method. Okay. Now, similar to the above two methods, we need to allocate these allocations to, we need to write the allocations to the initial table. I have already write the table here. Now we need to write the allocations. Here it is 5. Then in this cell there is 8. Allocation is 8. Here it is 7. Here it is 2. Here again 2. Here 10. Okay. So this is the final table we got. Then check number of allocations is equal to 1, 2, 3, 4, 5, 6, which is equal to m plus n minus 1. Okay, and all allocations are in independent position, so we can say that it is initial basic feasible solution. Then total transportation cost is equal to 5 into 2 plus 8 into 1 plus 7 into 4 plus 2 into 1 plus 2 into 6 plus 10 into 2. Okay, so the total cost we will get thus rupees 80. We have done the same question using northwest corner rule, lowest cost entry method, and Vogel's approximation method. So the lowest cost obtained the above three methods was, I think, 103, 82 and 80. So the lowest cost we obtained using the Vogel's approximation method. If the question is to find the optimal solution, first we need to solve the question using any of these three methods to find the initial basic feasible solution. I always suggest you need to choose VAM in order to find the optimal solution. VAM will get more exact answer. Okay. If the question is to find initial basic feasible solution, it will not specify any method, you can use any of these three methods. If the question is to find the optimal solution, then we will need to find out optimal solution, that is the exact lowest cost. So we need to done Modi method also. For that I always prefer VAM method in order to find out the initial basic feasible solution. In next session we can look at Modi method. Okay, thank you.